Hello everyone and welcome to a Cloud Standards Customer Council webinar. My name is Tracy Berardi and I'm Program Manager of the CSCC. Thank you for coming today. We've just published a new cloud reference architecture for the Internet of Things. And the aim of this guide is to help organizations like yours successfully deploy and support IoT systems using the cloud. So today I'm joined by contributors Heather Krieger, Mike Edwards, Eric LeBeau, and Gopal Indurkya, who will introduce the white paper and walk us through some important considerations and strategies. If you'd like to download the white paper, there's a link here on the title slide on your screen. We also have a link in the chat box in the GoToWebinar toolbar. We've also pasted a link in the chat box if you want to download a PDF version of this webinar presentation from today. So you should see both of those. We will, after the webinar, post a recording to our website, so you can look for that. It's the events section of our site. We should have some time for Q&A at the end of the presentation, so if you'd like to pose a question, you can do that using the questions box. And with that brief introduction, I'll turn it over to you, Heather. Thank you.
Thank you. And thank you very much for introducing us, Tracy. We're happy to be here. This discussion is actually going to be on IoT for the Cloud Customer Reference Architectures that have been being developed with the CSCC over the past year or so. And this is the latest in a series. If you want to look at this first page here, then you see there that we have IoT, the link to the IoT one. The other ones that we've done are big data analytics, mobile, and web application hosting. And there are links there to the papers and the webinars for those as well. This is actually an ongoing program, and we plan on doing additional ones as well, and so we're interested in your participation in those as well. Let's go to the next page. Let's just talk a little bit about what are these cloud customer reference architectures and why are they important to you and your business. So while we call them cloud customer reference architectures, they apply to customers and also vendors and cloud providers. So these are important concepts for all of us. So cloud customer reference architectures are straightforward descriptions of the elements needed to implement particular solutions, business solutions, and business capabilities using cloud infrastructure or cloud platforms, cloud software, or as services, cloud services. These reference architectures are deployment neutral. You can implement these capabilities and the interactions that are being defined here using public, private, or hybrid cloud. And you can also implement them using a variety of as-a-services. You can implement them using infrastructure as a service, platform as a service, or software as a service. So these are really at the capability level, and then we show you how the best way is to deploy these across the different kinds of clouds, cloud service options available to you and deployment options available to you. These are general purpose, and they are composable, so you can actually compose together the analytics ones with the other architectures. And in fact, we'll show how the IoT architecture ties back to analytics concepts in particular today. Why are they important to you and to those of us who are engaged in building them with great enthusiasm? Because they give us a common platform of understanding. So we're all on the same page when we're talking together in a community or between customers or between vendors about a particular topic and understanding how that domain maps down onto cloud computing area. This is important so that we have a shared understanding of the issues that we're trying to solve and the issues that we're trying to provide solutions for. It's also important because it saves time and money and gets everybody on the same page earlier when you're starting to create these reference architectures, since we do provide you some models for these. Provide you common guidance on how these might be affected and what some deployment considerations will be for you. And these are all vendor neutral, so you can actually refer to these in a very common way. So they're useful when you're starting to build things. They do provide sort of a 101 education level on the particular domain, a basic understanding of analytics and mobile, and today we'll talk about IoT. So next slide. Thank you, Tracy. Now, I said this was part of a whole series that we had in progress. You can see there we've had 3 already done, analytics, mobile, of application hosting, and today we're talking about IoT, and Eric LeBeau is going to go in great depth with you on this, and that was published on February 16th. We have others in progress and having conversations about others. If you're interested in particular in helping kick off some of these other ones that have been being discussed, please let us know. Next slide. And with that, I'm going to hand this over to Eric to take you through the details.
All right, thank you, Heather. So on this first slide, we're trying to show you just an overall, what does the picture look like at a high level. And you'll notice that the architecture itself covers end-to-end from the actual users of the system to the devices we're trying to manage to what we call cloud, or the cloud side, which is more of the middle, to the edge processing, as well as what's referred to as fog by some vendors. But so we're covering it from end to end, not just one perspective. And if we could get to the next slide. What we're showing here is that, and I'll give you a little bit of history here, we have lots of arrows and colors and everything else here, and you'll notice the legend on the bottom on the left. So we're showing you data and control flows, we're showing you user interaction flows, we're showing you what things are application related, what things are infrastructure services, what things are data-oriented services, analytics, security, and management. So the whole point behind this is trying to color code it to make it a little bit easier to understand. I know there's a lot of things that are on this chart, and I will go through all the little boxes and arrows and everything else as we go through this, but want to make it easier for you to follow it as we go. And the color coding was done on purpose to try and make this a little bit easier to digest when you refer back to this later. So if we move to the next slide. The first component I want to talk a little bit about is the IoT user, and that's the person who's trying to interact with the system. Typically, that is going to be somebody who's using, in this case, some type of mobile device and to interact with the system, and we're going to be able to give them some information about a particular physical entity, the sensors that are collecting some data. They may also interact with another application as well, and we're trying to bring that data together to make sense and give you a little bit of insight. So we move to the next slide. Would be the end user application, and this is the domain specific or device specific application. If we're talking about something that if you're trying to manage, for instance, your washing machine, because it's a connected appliance, this would probably be a mobile application that's on your device, whether it's an Android phone, and it would allow you to do some basic things like change some of the settings, see where it is in the cycle, those kinds of things. But that type of interaction that you'd be able to do with a mobile device. If we move to the next slide. Then we have the physical entity, and you'll notice that this is done separately from the actual sensors and actuators because depending on the device we're looking at, it may be all in one box, it may be separate. Case that I was just mentioning, like an appliance, a lot of those sensors are probably built into the appliance itself, but in a lot of other cases that we look at, especially in the industrial space, you may see sensors that are outside of the actual device, and those may be looking at things like environmentals. And they may not be part of the device itself, but those are things that may be separate. So when we refer to the physical entity, that's the actual thing that we're trying to understand and get insights about. And that's what we're trying to manage. If we move to the next slide, now we get to the sensors, actuators, and these are and the firmware. And why this is important to be separate is we look at this. This is more the compute power that's inside the actual device or the sensor. Typically, customers want to update the firmware that goes with this because understand that you're going to go out with a certain set of capabilities, but you're going to want to probably evolve that over time. The user interface to this is typically done via some kind of mobile device as well. And not only do we worry about updating firmware from the perspective of adding new capabilities, because we live in the world we live in today, security is ever evolving, and there'll always be new exploits, so you're going to want to have a way to update that firmware and to close those exploits. So those are the kinds of things that you're going to see customers wanting to be able to do with those. So if we move to the next slide. So we have application logic. This is the actual gateway, the things that can run on a gateway. And think about this a little bit beyond what you would in a typical network type gateway where all you're providing is connectivity. In this case, we may provide some storage for some data for where we may be keeping it a lot more granular level of detail than what goes up to the cloud. We may perform some basic analytics at the edge, so we can do some filtering, some summarization. I might actually take some actions based on some data I get at the edge, and that would be some of the application logic. And the reason why this is important when you're looking at an IoT solution is as we start to move forward and we gather lots and lots more data about different devices, especially when you look at things like audio or video analytics, that's a huge amount of data, and I only want to send exceptions to the cloud. And in a lot of cases that some customers I've been working with where they're getting literally hundreds of samples a second from some of the sensors, they may only need to get 1 second intervals to send up to the cloud. So I can save a lot on the amount of data that I send up. And that also becomes very important when you're talking about non-continuous connections, so you can't think that bandwidth is unlimited. A lot of these devices are going to be connected with things like 3G or 4G, and that data and bandwidth is expensive. So trying to send up only what I do need to do the analytics in the cloud, but be able to do some of the filtering at the edge becomes very important. If we move to the next slide. This is where I want to call out something called a pure cloud. And in a pure sense where you own all the pieces, this probably doesn't exist because the actual devices would be connected to your cloud. But the reason why we call this out is in a lot of solutions, and if I'll use an insurance company as an example, they don't want to own the experience that you have at home, for instance, with connecting sensors to your gateway and making sure they can talk on your particular home network and that they're working. So there are other companies that do that. Be it Wink, who's sold at Home Depot, or things that are sold at Lowe's called Iris, and there are other companies like ADT, et cetera, that have lots of other sensors. They've already got all this data and they're connecting it to their own cloud. And if you're trying to bring this into a bigger solution, you would do a connection to their pure cloud and just do a data flow as opposed to doing the actual management of the devices and the sensors themselves. But obviously that data is very important so that I can get the insight. So in that case, you would be connecting to a pure cloud and bringing that data into your system. So we can move to the next slide. And then we have edge services, and this is basically how we're going to allow you to connect into the system that exists, the cloud. It probably has a firewall. We're going to have load balancing so that we can have redundancy and a way to eliminate single points of failure. And it allows you to do name resolution, et cetera, and allows the data to flow. So we can move to the next slide. And then we have IoT transformation and connectivity, and this is probably very important when you look at things from providing secure connectivity. We want to have scalable messaging, so you're going to probably want to have some type of bus architecture here, and scalable transformation, because these messages are going to come in various formats, and obviously I need to turn them into a format that I can use them. And in some cases, they may be a binary format message on the way in because I can compress that and make it very small. And I need to put it into a format that I can actually understand it and perform analytics against. So I'm going to have to do some level of transformation at this point. That needs to be scalable. I need to be able to deal with the fact that I may have many, many, many messages coming in. So I need to be able to queue them and be able to process them in a timely fashion to run the analytics that I need to be able to run. We can move to the next slide. Then we have an end user UI, an admin UI, or dashboard. This is basically web-based, and this visualization that we're looking at here has these three personas here. So I may have an end user UI that allows you as a user of that device to log in and see what's happening. An admin UI, which would be somebody who's actually trying to administer this overall IoT solution. So they may be doing some configuration type of activities there, et cetera. And then when I think about a dashboard, I think about that as like a line of business type person. So if we're thinking about the insurance aspect, they might want to understand how many of their particular users are having a problem at any one time. So that I can start to see more of a visualization from a line of business perspective. If we move on to the next slide. We have the device registry, and this is basically where we're going to go ahead and log information about the device so that we know that what it is, how do I communicate with it, some basic aspects of it so that it's I know it's secure, I'm not getting spoofed, etc. I also know how do I communicate back to this device so that I can, and what is available to do to this so that I understand what actions I can take against it, if I can, of any, and also what are the firmware levels and things that I want to be able to update in the future. Next slide. So we have device management, and this is a key, like I had mentioned before, about being able to take a device. I need to update its firmware. I may need to, if I'm starting to see bad things happen with it, I may want to take it offline. I might want to do some other, that device itself, as far as enable new capabilities, etc. So it's something we need to think about, lifecycle management of that actual device itself. So that's one of the key aspects. It's not just important to connect a device, but I need to maintain it. And in the case of a lot of these devices, if you think about an appliance, the typical lifespan is at least 10 years. So you want to be able to think about what can I do with it today, but what am I going to do to this from a software perspective over the next 10 years? And they are actually starting to manage applications that are running on these devices. So it's a new domain for them as well. So if we move to the next slide, we have the device identity service, and this is how I can securely identify a device. I want to be able to ensure that I'm actually getting data from the right device and I'm sending data to the right device. So this is an important aspect from a security perspective of being able to make sure that the device is who it says it is. Next slide. And we have API management, and this is how we start to allow other systems to interact with the device. So we can expose just certain capabilities, not everything, in more of an API economy, and allow different systems to either get access to certain aspects of the data. Maybe we're going to mask that data so it's anonymized, but I also want to allow them to do certain maybe controls of that device, so that this allows you to expose not everything that you've built and all the capabilities of a device, but you can expose just certain capabilities to certain users. And it also allows you, by exposing them as the APIs, we can start to manage them from the perspective of billing and logging, so I understand who did what and how often did they do it. So if there's a billing aspect to this, you can do that. I also have an audit trail, which becomes very important. If we move to the next slide, we have application logic, and this is just typical core application type logic that you'd have going on. This is probably running on some type of runtime in your environment, whether that be Node.js or a Java runtime environment, whatever your favorite language is. But you can start to write some of the application logic at that level. Most clouds today support a variety of these different application platforms, so you can pick your favorite thing, whether it's Python, like I said, Java, JavaScript, pick what you want and write appropriately. If we move to the next slide, analytics. This is pretty much the reason why I'm collecting all this data to begin with. I want to be able to start to get some kind of insight out of this data. Just collecting it doesn't mean anything. I obviously want to do something with it, or why am I bothering spending the time and money to connect the device in the first place? In most cases, you're going to see a variety of types of analytics available to you, whether they be real-time streaming type analytics, whether I want to do predictive analytics. You definitely want to start to look at things that are cognitive, and I want to be able to get the, like I said, the actionable insights so that I can start to actually take some kind of action based on this new information that I have about a device. You're also going to have to think about what kind of storage I have with this, what kind of data do I need, short-term, do I need it long-term, do I need to change the fidelity of the data, what kind of access do I have. A lot of this starts to play into what you do with the data stores, because it can become pretty expensive pretty quickly if you're keeping all the data forever. So you want to start to think about this in the context of the use case of the analytics and what I want to do or might want to do, so that I can start to apply that against the kinds of data store that I use. If we move to the next slide. Process management, pretty much all the workflows that you're going to do, the data that comes in, I'm going to have some level of workflow. And an example of this, if we're talking about going back to my example around an appliance, when it first checks in for the first time, I have a process flow that says not only do I want to register this device, but I might want to register it in a warranty system that's on-premise, and that will go through the connectivity to an enterprise application. But this is the kind of workflow that I want to start to be able to build those kinds of things. Or if a certain kind of value is determined, maybe I want to kick off an enterprise workflow that allows me to schedule a work order to get some maintenance done, if we're talking about an industrial setting, based on some of the issues and things that are detected from the sensors out in the field. So if we move to the next slide, this is the device data store, and this is what I was alluding to before. This may be multi-tiered. It doesn't necessarily have to just be one kind of data store. You may decide to keep a lot of the readings you get off there, the device, at a certain level of granularity, and then over time I may move it to a less expensive storage. It could be block storage. It could be different types of storage depending on what you're trying to do, and trying to get to the least expensive for the long-term storage, but I may need quicker access to things for the short term so that I can do local analytics and do it real time. If we move to the next slide, this is, again, very similar to the edge services you saw on the other side in the transformation and connectivity, but this is going from the cloud into the enterprise. This is very important because most systems that you're going to be building are probably not self-contained all in the cloud. They're going to interact with some level of enterprise data or enterprise users and enterprise applications. So therefore, we have to have a way to transform some of the data on the way out, make some of those connections, get access to some of the data that's in the enterprise, maybe feeding data into the enterprise for certain things like I mentioned, the warranty system kinds of applications. If it may be a work order system, I'm going to try and interact with that. So I have to go through certain levels of connectivity and then transformation there. If we move to the next slide, we have an enterprise user directory, and this is basically how I'm going to be able to have users authenticate. This is like typically an LDAP of some sort in the user's environment, and this is basically this is something that we've had to use pretty much in every system we've built to date. Integrate with some level of directory that an enterprise user has, and that would allow you to do some of those visualizations we talked about before, and allow those users to authenticate. Because in pretty much every case, they're not going to want to build another set of credentials, store that somewhere else, have another password to yet remember, and if they've already got an enterprise directory. They'd like to just be able to enable one of their enterprise users to have access to certain additional applications and just leverage that directory for validation. Just typical type of thing that we would build with in any enterprise system. If we move to the next slide, enterprise data, this is where we're going to get context. There's all kinds of data that we may want to either add to an enterprise store or read from that so that we can get better context about a device. And it typically can range from anything from historical data to reference data. If we're talking about something in an industrial setting that we're managing, I might want to understand when did we buy it, how long has it been in service, what kind of previous service history we've done to it, those kinds of things that I want to understand. So there's lots of interaction here. How many times has it had this particular type of problem or this reading that came up? So there's lots of enterprise type storage that I might want to bring into the picture and start to understand a better reference of what's going on with just this device, as opposed to just I have a device and I got a particular reading off it. So I want to try and get a better overall picture and or provide some of that data to some enterprise stores. And in the case of the work order system, I want to write down that I got certain readings at certain times so that they have a log and they can see, is this particular device having a history of a problem? And is it time to replace it? Those kinds of decisions can be made and enabled by having a really good log of what I've seen in the field. And it's not dependent on a human to actually write it down. Next slide. Enterprise applications, this can be any number of applications, from your accounting system to we're showing in operations and fraud. If we're talking about an insurance application, it may be that their claim system. So if we detected, for instance, water in your house with a particular sensor, maybe we want to kick off a claims process. Or if you think about it in your car where they have sensors that detected you've had an accident and airbags deployed, they can kick off, again, a claims process there as well. If we're looking at things like taking some of the things that you get, sensor readings, and combining that with some of the weather, you can start to understand what kind of risk is going on. So do I have a lot of cars that I'm insuring that are in a certain zone that is expected to get a hailstorm to go through it? So what's my risk look like? And it also allows you to enable new business models. And in the case, like I'll go back to my appliance example, now that I know that how many cycles of wash you do every week, I might be able to make a deal with the soap powder company, be that Procter & Gamble or somebody else, and offer you to deliver that soap to you directly at a discount. And therefore, me as an appliance manufacturer now have an opportunity to increase my overall footprint and sale with you. And so I'm enabling new models of things that you can do. So that's one of the big things around IoT is customer engagement and new business models. From a customer engagement experience, a lot of these devices that are sold through third-party dealers, the actual manufacturer never understands who you are, and because you don't register the device, most people never fill out those warranty cards, and I'm guilty of that myself. But if you have an electronic way of registering and they're offering you something in return, like connectivity to your device, so you can see how it's doing, now all of a sudden the manufacturer knows who you are and has a relationship with you, and that becomes very important in looking at these IoT solutions. If we move to the next slide, we have security, and you'll notice that security goes all the way across the bottom, and that's important because you need to secure the entire stack all the way across. So we have identity and access management, so that will be understanding who you are, protecting the data for sure, security monitoring, so I want to understand, is somebody trying to spoof me and send me bad data, and also understand if we're being hacked, and system and application lifecycle management. That's what I was talking a little bit before about, understanding that security is going to evolve over time, and I need to be able to take actions and be able to change settings and apply different things and techniques to my device over time. So you need to think about all this as an ongoing process. Security is not something that you're going to do once in an IoT setting. I will have an initial going out point, and I will start with that. But you need to think ahead and think that I will have to continue to evolve this over time, just like you would in a closed IT system. Next slide. I'm going to talk a little bit about IoT governance, and this is definitely very important because you need to think about the lifespan of a device, plan for smooth, non-disruptive either changes to firmware, and give you a good example of that. You have electric cars or electronically controlled cars. Tesla is an example. Almost everything in their car is done with software. Obviously, they wouldn't want to make a change to the software of your car while you're driving it, where it reboots everything. So a lot of these things, you need to start to think about all that as they go, and that goes just as well for your washing machine at home. I wouldn't want it to do an update to my firmware in the middle of my wash cycle and stop it and leave my wash sitting there. So all those kinds of things need to be thought through, and obviously depending on how critical the system is, like the car, it has a lot more importance. It's one thing to stop my wash, and it's another thing to have my car turn off in the middle of the highway. So all those things need to be thought through, again, as part of the life cycle of the device. And you need to have controls in place to allow or to prevent people from making mistakes at the wrong types of problems. If you want to move to the next slide. So if we look at all the things here in the cloud, that's what we are referring to as platform as a service. It includes everything that's sitting inside the cloud space. And a lot of cloud providers provide that as an integrated solution for having all those capabilities available to you. Not that you need to use all of them, but they have them all available as a solution. Next slide. And this is the overall details. Again, this is showing all the arrows, all the everything in here, from the user interactions, which are going to be the gold arrows, to the data and control flows, which are in blue, and showing all the different components. A lot of this is explained in excruciating detail in the white paper. But if you have questions, please post them into the chat about this. But it is a pretty complicated diagram when you bring it all together and have all the arrows and the flows in there. And with that, next chart. And I think, Gopal, you want to walk through this example?
Sure. Thanks, Eric. This is Gopal Indurkya. I'm one of the co-author for this paper. And Eric has explained the architecture. Now we use this architecture. We leverage that architecture to go through this scenario, which is for the smart home insurance scenario. Eric touched a little bit on, insurance scenario, but I want to explain that a little bit in more detail. What's the problem we solve? What's the advantage for insurance, and what's the advantage for the policy holders? And then I will go to the runtime flow. We have grayed out some of the component, but does not mean they are not part of it. But we just want to highlight the numbers to go over this runtime flow. So the problem, as we know, all those who live in the house, is that sometime, under the kitchen sink water, you will notice, I notice time to time, and sometime you will have the water leakage because of, freezing temperatures and pipe get burst. I'll share a little bit about one of my friend, how he struggled. He was in Orlando in the last winter. It was very freezing, and then one of the pipe in his attic got busted because it was frozen pipe. And 3 days water was leaking. All 3 floors were damaged along with furniture. And then he came back and no notification. And then when he came back, he saw this chaos. He has to call insurance, and he has to stay in hotel, etc. But insurance did not cover everything, because some of the things you don't have all the inventory, what you purchase, etc. But to avoid this kind of problem, if there is a notification or monitoring, and that's where this smart home insurance scenario kick in. So what you do, so there are a couple of advantages for the insurance. One is they can provide the improved service to their policyholders. They can gain insight into the risk for your home, and also there are advantages for the policyholder or homeowners itself. They get notification. They can also monitor, and they can get alert. They can shut off the water flow, etc. So how we do this, right? So first we start here with the numbering, and pay attention to the number as I go through. And we have more detail in the paper on page 17 if you want to go through the more detail for the runtime flow. So first thing, you will buy the sensors, which is, you can buy the sensor for the water leakage, for temperature to find out whether it's a freezing temperature, also for the water flow itself. So water leakage, temperature, water flow sensors we recommend, and then also you can have an actuator which can shut off the automatically water supply. So those are the ones in number 1. And then the way I think Eric already explained very well. So your devices, the sensor actuator, will work through the IoT gateway, and from there, once you connect, then it goes to the peer cloud, which is the device maker cloud. And as Eric mentioned, like here in US, you can buy these kind of sensors from Home Depot or Lowe's, and Wink or ADT or whatever those companies, they will run their service in the peer cloud. So we call it device maker cloud service. Now, number 2, this is where customer has to, or homeowner has to download the app from the insurance company on their mobile devices, and then they have to get the data, about the policy and detail from the enterprise data, and that can be done based on how insurance company provide the access to the mobile. They can go through the security and go directly to enterprise network, or go through the provider cloud. So those are the number 2 for the homeowner to log in and then give the authorization token and also the policy detail or identifier to the peer cloud or device maker cloud service. What it does actually, once homeowner log in and provide this authentication token and policy identifier, then cloud, the insurance cloud service can access the data into the devices, and that's the key thing we need to do through this provider cloud. So provider cloud is the one insurance is using to get to the access to the data on the devices, and also the details from whatever the sensors and actuators need to do. So that's number 2, and then 3 is how you do that. So basically, you have to map the user with the devices and insurance policy. So basically, number 3 is providing the linkage. Number 4 is once you have this linkage available, then application logic will do the data mapping. You will have the device registry, you will have the details of the devices, you will have the device data store with the policy detail. You may not have the exact policy number, but policy identifier will be stored and some other relevant information. And then they can access and pull the data from the devices through accessing the device maker cloud service. So that's what is that number 3 and 4. 3 establish the linkage, 4 does the data mapping and get the actual data. So number 5 is when you are doing this kind of situation with the water leakage, then you also focus on some other services like weather service. Whether it's a freezing outside, and then you have more chances of busting the pipe, so you can be, so in the analytics we can figure out what precautions can be taken based on the weather. And that's the other service can run in the weather service can run in the peer cloud, and then we can get the access to that data into analytics. And then analytics will determine when we pull the insurance company application, when pull the data from the device maker service on periodic basis, then they can also analyze based on this weather information that, okay, the water leakage may be more probably possible because of the freezing of your water pipes, or it may be based on appliances, or if it is a water heater, or if it is a dishwasher, whatever is the case, wherever you provided the sensor for the water leakage and water flow, etc. So analytics can determine based on the data pulled that, oh, there is a water leak, there is a possible water leak. So alerts, the number 6 is alerts can be sent, or notification can be sent to the homeowners and also the insurance company, which is an enterprise application on the right hand side. Once there is a threshold for determined for exceeding any kind of damage or situation reaching to that damage situation, either case the notification gets sent, but if damage happened, then insurance company can initiate the claim process for the homeowner. So that's what they will do after receiving the notification. And then number 7 is the process management running in the cloud. So insurance companies choose to run the business process for the claim itself, they can do that in the cloud. There are a lot of advantage of this. One of them, I will say, this is easy to implement this kind of solution and maintain it because of the cloud. You have the scalability and elasticity with the volume of data and velocity. Last thing is, as demand increases, more resources can be added, and that's the another advantage with the cloud. If you have any question, we can address in the end. But with this, I will hand over to Mike, who will talk about the open source mapping for this architecture. Mike?
Thank you, Gopal. Okay, so we've got the slide up that deals with some of these open source mappings. I'm curious, not everything seems to be displaying at the moment. Can you make sure that all of these, there we go, that's excellent. It's all displaying there. I think it's easy to see them all at once. So clearly one of the things you may want to do is to build a solution like this using various pieces of open source, and there's a good deal of open source available in various projects that will help you build your IoT system. So if we start out on the left-hand side of the picture here, one of the things that's available that is very handy for doing the remote work, connecting devices into the cloud platform that you're going to use to build the core of the system, is the ability to use open protocols. Of course, it's perfectly possible to use standards such as HTTP, which is widely available, to connect your devices into the cloud system. But HTTP isn't always the most suitable protocol to use, particularly when you're dealing with small messages and where you're dealing with communication links that maybe either have narrow bandwidth or even intermittent, particularly, for example, where you're doing calls over a mobile network where you don't want to keep sessions open all the time. And there are protocols that will help you with that. One of the ones that's available is the Open MQTT protocol. That's standard at Oasis, which has some implementations in the open source arena that are very useful and are also well designed for small devices. They have a fairly small footprint that will allow you to connect then your devices back to your cloud environment, where again you would use an MQTT server, for example, running in the IoT Transformation and Connectivity component. Moving on round, going in a clockwise direction, we then have stuff that you may use for API management, for controlling access to the APIs as we discussed before. And there are a number of open source tools available. There's the WSO2 API Manager, or TYK, and MuleSoft. They all have facilities that give API management capability that you can use. For the device registry and the device management capabilities, there are a number of open source packages available. We have WSO2, which have some of those capabilities, TYK, MuleSoft, Siteware Car, and so on. There are a whole series of facilities that are available in that area today. Continuing on round in our clockwise direction, if we look at enterprise user directories, then we have in particular Open LDAP available, which is a very good implementation of LDAP, which is great for user directories. And then in the more cloud-oriented arena, we have the OpenStack Keystone project, which can be used for the same sort of things. Again, in the enterprise area, we have, for the enterprise data, a whole series of different databases available that could be used. We've quoted a few of them here: MongoDB, CouchDB, MySQL, Postgres, and Hadoop if you wanted to do big data kind of analysis. So all those are available for implementing your enterprise data. Transform and Connect, over there in the middle of the right-hand side, there are tools such as ActiveMQ, TYK, and MobiSense available that can do the transformation and connectivity task to connect through from your cloud environment into your enterprise network. Moving on further, there's then the question of application logic, and in the open source world, actually the world your oyster, that we could list a great many different open source platforms you could use on which you can run your application logic. We've given one of the more popular ones here of Node.js, but there are plenty more open source runtimes available for all kinds of languages. But Node.js is one of the more common and popular ones. Moving on around again, down towards the bottom, we have the device data store, and like with the enterprise data store, there are a whole series of databases available: MongoDB, CouchDB, Hadoop, PostgreSQL, various forms of object storage available as well. And there are also some open source graph databases which are beginning to become popular and which can be useful in some of these IoT engagements. Moving on around process management, there are some very useful open source process management tools available. We've listed a couple of them here, but we've got Activity and Process Maker, for example, which can be used to implement the process management capabilities that you're going to need inside your solution. And then further, we have at the bottom here the analytics capabilities, and here there are a whole series of analytics capabilities available in open source, and we've listed a few here again. Hadoop, Spark, which is becoming a lot more popular now and becoming the basis of a lot of analytics programs. Pulsar, Mahout, Jupyter, I could name more and more, but there are a wealth of different types of analysis and analytics programs available, which will suit different kinds of analytics that you may want to do with your data, whether they are big data handling such as Hadoop, or whether you're dealing with streaming data and trying to analyze data on the fly as it streams into your system. For visualization, going around a bit further, we have potential to use Data Wrapper, Angular, Chart.js, Lumify, Freeboard. There's a whole series of tools that are available to help with visualization of data, which can often be a big factor in producing the kind of applications and dashboards that you need in conjunction with an IoT system. So a wealth of possibilities there too. Moving around to the bottom left, we have the potential to run all of your components as a platform as a service style offering, somewhat lighter weight approach than doing everything on VMs on the machines. And there are some very useful open source PaaS platforms available. Cloud Foundry and OpenShift are some of the leading ones that you can use, and that would enable you to have a simpler approach to the deployment of your applications and the services that they're going to depend on. And then last but not least, just above the PaaS is the set of open source stuff you could use to do transformation and connectivity on the way in to your solution from the IoT environment, the internet environment. And here then you'll be looking to transform and connect stuff, and here we could be using things like ActiveMQ, DYK, MobiSense and so on to handle the streaming in and out of data between the cloud environment and the IoT environment, and indeed the applications that are running out there with the user. So lots of interesting and useful open source solutions that are available to implement parts of this architecture. So it's a very rich environment that you can use today. So moving on then from that slide, we have the next slide, please. Right. And this is just a call to action for those of you who are involved in cloud-related activities and indeed IoT. You'd be very grateful for you to come and join the Cloud Standards Customer Council. We have the 500+ members already on board. But CSCC aims to have an impact on customer use case-based standards requirements. What standards do we need to enable these modern systems? And we're able to learn all about cloud standards within this one organization, and you as a member could help define the future roadmap. What are the important things that need to get done, need to get covered? Membership's free, very easy. There's a link on this page to the website of Cloud Council showing you how you become a member. And once you've joined, you can join the various working groups that produce architectures like the one we've been discussing today. And last but not least, there's a load of cloud computing related collateral available on the CSCC website, including this architecture, but a lot more too. And if you visit that site with the link at the bottom of the page here, you can find a lot of good and useful materials to help you with all sorts of cloud-related issues. So with that, I'd like to hand back to Tracy to conclude today's webinar.
Thank you, Mike. It was great. And Gopal and Eric, of course, and Heather. Looks like we have plenty of questions. So let me take a look. First question. I think it makes sense to have an API management component as the only way into the application logic. For instance, analytics can leverage an API and get the data for the end user. Analytics can be a hybrid component, partially on the cloud. Any insight that you have would be appreciated. Not sure if anyone has some thoughts to add here.
Well, this is Eric. I can give you a little bit. API management makes a lot of sense when you need to do some billing and control. So typically that's to give third-party access to those types of things. But if we're talking about internal access, usually go directly to the data and avoid the API layer if you can, just from a speed and an ease of use capability.
Mm-hmm. Eric, this next question is directed towards you. In your piece of the presentation, you talked about identifying and authenticating the device. What about the opposite problem, making sure that the device can authenticate what it is talking to? What additional capabilities does this require, and where would that reside?
So we usually have a set of keys that are exchanged, typically. So there's a piece that lives on both sides to make sure that we're communicating securely in both directions. And you can also go further than that, where there's authentication that's actually burned into the chip when it's actually built. And those chips, as they're put into additional devices, those are pre-registered in the platform that you can have access to. And therefore, you have that security in both directions built into the device at a hardware layer. So it can't be spoofed.
Thank you. Okay. Can you talk about where communication protocols are handled? If the device itself doesn't talk, DDS, for example, is this the role of the IoT gateway?
So in many cases, especially when you think about a gateway that you use in your house, for instance, those talk probably 5 or 6 different protocols. And they will translate that into a standard protocol and communicate that to the cloud. So yes, the gateway will do translation in those cases.
Mike Edwards here as well. Yeah, if you look at the architecture that we've got, we actually have something we call the proximity network, which is where the devices and the gateways tend to live. And it's common in IoT systems to have these specialized communication protocols and communication networks going between the devices and, say, a gateway, typically because they're low power, limited area of extent, and so on, because of the very nature of the devices, which tend to be small, low power type things. So there's a need then to translate between those kind of networks and then the internet over which we're going to connect up to the cloud environment. So it's common for these kind of translations of communication to be going on, and the gateway is a typical place that might happen.
I just want to add this, Gopal. You can use Zigbee or Z-Wave or IP-based, like if you have some kind of network at home. So depends on that. You choose or decide the protocol for your device.
Okay. The device box seems to require some computing capabilities that a legacy device or a very cheap one might not be capable of. How would this modify the architecture?
So if you're looking at building these things, I've been working personally with some appliance manufacturers, and they've gotten the cost of this device down to less than $1, the compute power, in the quantities that they're looking at to do some basic computational things. And the price of these processors has come way down. I mean, you can get a Raspberry Pi, and that's something you buy one of that costs less than 20 bucks. So the actual compute power that's required is come way down, and it's from a price perspective, as well as what it can do, has come way up. So you'll see a lot more devices that are IoT enabled that have some compute power that are built into them. And for legacy devices, you're going to be limited to whatever they can do today. They may not have a lot of compute power, but there's a lot of things in industrial settings that already have a lot of these type of telemetry systems that are built in. And in that case, like we talked about with gateways, you'll bridge into those existing networks and take advantage of the capabilities that those devices already have.
Okay. Anyone else, or I can move on to the next question. We have a few more. It looks like we're about 5 minutes. This question, security seems to stop short of the user layer, which I think was just, that's how it appeared on the slide. But is that due to a lack of positive control at the user layer?
No, it actually goes all the way across. It just, we had to make space for the legend.
Right, and also user layer is independent of any other layer, right? User can be in the enterprise network or provider cloud. So that's another reason, that layer is independent of all other.
Okay. Then how is the enterprise network secured from the cloud provider?
Typically, a cloud provider provides some layer of VPN or other types of services that allow it to connect between them. And they provide various types of things, either at an API level or a VPN level, depending on the provider.
Yeah, I mean, just flipping it around a little, typically the enterprise networks are very much behind firewalls. So it's actually, you have to actively enable a connection to take place between the cloud environment and the enterprise network. And that was, as Eric just said, there are a number of technologies that are used to do that, but it's typically something you positively have to add into the system to make it possible.
And this will be the last question relating to privacy and confidentiality. The recent Apple issues with encryption show that there's a huge interest in this topic, privacy and confidentiality. So what will the IoT cloud be doing to help integrate that into the architecture? For example, I may not want the insurance company to know how often I wash my clothes.
So when it comes to that, it depends on what we're talking about. If you're going to have to opt in for most of these services. So if you're talking about wanting the manufacturer of that appliance to know how often you do that stuff, you're going to have to read very carefully what they allow. And in most cases, what they're going to share is going to be anonymous data above that. But for their own use, they're going to have all that detailed data. And that's why it's going to be a trade-off. And you're going to have to read carefully and understand they're going to give me some advantages with connectivity, but there's the disadvantage of losing some of that privacy. And that's going to be a dilemma. I mean, we have it today. If you think about the insurance industry and the little dongles that they give you for your car, you're basically giving up your right to say that I don't want them to know exactly where I drive, when I drive, how I drive. They know all of it once you plug that in.
Yeah, I think one of the big things in this area, certainly happening in Europe, is that there's going to be a requirement for the organizations that are gathering the data that has personal information in it, like where you're driving, and so there's a classic example of that. Have to make clear use statements to the end user, to the customers out there, about what is happening to their data, what are they going to do with it. There wasn't so much of that in the past, but some of particularly the politicians have got very, very sensitive to that. And so there are regulations coming along that are force this on all the providers to give clear information about what's happening with the data. But you're right. If you sign up to a particular service, you have to read what it says. What are they doing with your data? Could be anything.
Yeah, and as viewer mentioned.
Yeah, I would like to add some more on that. Actually, we do have a data protection section in paper where we describe the privacy. And also we have some more scenario there, IoT for health, where privacy is very important. So just want to mention about that. Go ahead then, Tracy.
I was just going to say that viewer suggested that perhaps we work on some opt-in contract language that would be recommended in these scenarios. Something to think about. Great job. Looks like we're right at the top of the hour. I appreciate everyone's time today, everyone that could join us. We will send out an email following the webinar this afternoon, so you have a copy of the presentation if you didn't already capture that in the chat box. Also, a direct link to the white paper, which you could find too on our website, cloud-council.org. ccscc.org. So thank you, everyone, and have a great rest of the day. Bye.
Thanks, you too.
Thanks, Tracy.
Bye, everyone.